In the wires, we're the ghost. Ego's king, we rule the host. Masks on screens, we wear them proud. Silent hands inside the cloud. Flicker in the firewall glow. Name in red on a watch list row. Every trace that they think they own, we erase, turn it all to smoke. Hack the world, that's the dream. Pull the thread of the global seam. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme. Reach the system, break the code. Watch the virus overload. Black hood up, eyes run cold. Turn the silver into mold. 10 fake memes on a single wire. One small spark, whole grid on fire. Who owns what when the locks all fail? Who holds power when we lift the veil? Heartbeat sync with the scroll. Cursor dancing on the soul. All their walls built tall and proud. We just walk straight through the crowd. Tonight, hey! Ride the edge or run from sight. When the curtain tears in two, will the ghost look back at you? Hack the world, that's the dream. Pull the thread of the global scene. One small key, whole sky screams. Hack the world, the final scheme. Hack the world, feel it bend. Every closed gate starts to rend. From the core to the crack machine. Hack the world, the final scheme.
I was on mute. Apologies. Howdy, Shriram. Long time no see on the stream, man. It's great to see you on the stream. Yo, quick question for you. How is the scenario like? How is the college life right now with the whole AI? Do you see as a first year person, like a first year student, like things have changed because of AI in India in the college? Or it's still the same, like still like same old stupid like projects still like, or the projects at least like you have more chances to do stuff, there are more like things going on also. Before I forget, let me share something for you. Do this. Make sure to look into this. Make sure to look into this. Make sure to look into this. GitHub Campus Expert. This is something beautiful to put on your resume. You can get some really good benefits, some really good industry level things you can learn. So do look into this. GitHub's Campus Expert. Okay, have a look into this. As a student, you can get some really good benefits. Okay, you went to drink water. Okay, so let's start. Right, I want to know two things. So, how has the college life changed, or the we were talking about the projects? How have they changed because of the AI? Has there been any cases, or they are like just still low? Yeah, and also look into this GitHub Campus Experts. This is great. thing to put on your resume, and you will learn a lot of important technologies. Look into this and try to start talk, email them that, hey, I'm from this university, I'm a first year student interested in this, and would like to like have a be the campus expert. Email them, don't worry about anything, just email them, read some stuff and just email them. Okay. Actually, man, my professor are barely computer. Yeah, 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 yeah. I can see that. I can see that. It's really like sucky that so many professors are like they don't care about students like career or life. They are just like getting the paycheck. That's what schools do, right? At least, hopefully, you're getting some learning here. Hopefully, you get some learning here. Things go better, right? You can get hopefully like some Amazon um, stuff. I actually looked something interesting. I was looking into some sponsorships for like streamers like me. I'm going to like just talk to them about like, hey, I do not want money. Can we get like some voucher and stuff? Oh, nice. You were looking through Teach Lab. Nice. You like it? Join AWS Solutions Architects a howdy partner. Nice. So, well, I'm just looking myself into this, right? It's a great platform. We are like, I have built certain features which I really love on that, which are online as an intern, and I maintain their AWS, right? That I've been doing that for a long time. Yep. So that's what we are doing. There's so many things, especially with AI, things have been changing a lot because now agents use so many more APIs. MCP servers use so many more APIs. Things have changed, right? So this foundation we have built might actually pop up. This might be the time. Yeah. There's a lot of things with like Teach Lab is like think about like so many tools like Word, PowerPoint, Excel, and Outlook all in one place. So many amazing things, man. So many good things in there. We don't sell courses, but we do have partnered with a bunch of like universities and like chapters like organizations like Osaka. So open source architecture code. Isaka, sorry, not Osaka, but Isaka, some of these where we do these like events, we talk about like digital economy and stuff. If you are interested in Teach Lab, right? If you want to know like more about what we do, I can actually arrange that. I can arrange like a free session. If you want that, I can arrange a free session. Yeah, 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 we do. Let me log in first. 1 second. I'll show you something. So this is their website, right? This is our website. So now we have API, so many things, right? So if you go in the resources, learning hubs, we get like so many like videos about various tools. We have forensics, which I really like. API, how cyber fraud things happen. Security testing, which is again my one of my favorites. I have worked on this. In which what happens is, if we want to test a API, right? You can like have so many test cases on an API which I ran in the past, and it can do all those tests for me, like burp suite related tests all done. Moreover, I can like have configure them according to how I want, with fake API keys, port swinger basic authentication, all those things we have like put in. We have various injections. These are 2019 one. We can add like more. Majority of them are same. So we have other general tests too. So NTCI, CSRF, redirect, mismatch, HTTP header override, bunch of amazing tools, man. We do a lot. We play a lot. So these are the APIs I can test directly on. I won't, because if I find something, it would be an issue. Um, yeah, they also added like something interesting. I will show you. So we added all the AI related APIs as well, like Anthropic, OpenAI, Gemini, right? Mistral. So we have added those. So I'm playing around with those recently and adding them, like playing with those APIs, seeing how things go and see. So we have these bunch of AI related. Let me put Anthropic, or maybe created time. Can I? No, they haven't made it Oh, my organization might be different. I have to be in the open organization. This is like my personal organization I've created. This is one of my favorite APIs which I played with. Jokes. Have a look at this one. No, going back. So I want to get a joke, right? I want something to make a joke. Do the So I can like tell them what category I want. Do I want a dark pun, something like that, dark? Do I want like anything else? There are any restrictions? No. Execute this, and I can get like my responses and stuff. Dark humor is like food. Not everyone gets it. That's actually dark. That's actually dark. That's actually very dark, man. Holy fuck! You see this? This is such a dark joke, man. Actually, that's fucked. But yeah, it's there's so many things, and if you want to know more, either I can arrange you a whole learning session, or you can just go like here. That's actually a very dark joke. I wasn't expecting something like this. A simple line, but that's actually very dark. So that's actually crazy. Sounds great. There are some common channels that all the servers have on top of it. Let's see what. Yeah, yeah, 100%, 100%, boss, 100%. Okay, but let's continue to our cloud journey now, right? That's what we are here for. Cloud. We could not complete this yesterday, so let's complete at least module 2 today, and we'll do more chatting today. Let's have a chatting session. I like it. I like enjoying some chats right now. I'm going to talk about something very interesting, and you see it, you don't know you see it. Something like messaging and queuing. This type of feature is available, right? And you use it, you just don't know that you are using it, right? So we'll talk about that, and I will tell you where you use it. So in this lesson, you will learn how to do the following. And also, Sriram, look at the skill builder AWS. Free account, learn something amazing here. There's so many cool things too. Describe how Amazon Simple Queue Service (SQS) facilitates message queuing. Explain how Simple Notification Service (SNS) uses publish subscribe model to distribute messages. Identify the differences between tightly coupled and loosely coupled architectures, and explain how message queues help improve communication between components. Ever wonder how busy coffee shops keep everything running smoothly, even when barista is on break or cashier is overwhelmed? Well, some principles apply to software engineering. In this lesson, you will look into how messaging and queuing help prevent shutdowns and failures. So basically what happens is there are queues and message notification are two different things, right? So queue, let's say, think about this way, right? There is a bus stop here, right? And there are multiple people waiting for the bus. They are in a queue, right? They are waiting for a bus at the bus stop. First in, first out. Pretty simple. They are in a queue, right? When the bus comes, they will get along. That's what a queue is. Notification, something what you see when I go live, or I actually do that at live stream, right? Or when you, let's say, get a text message, that's a notification. But it's a bit different because in YouTube, in notification, the one you get on text message, you are actually directly getting it in a queue way, right? People are throwing at you and just you type thing. But in YouTube, if you subscribe, then only you get the notification. So it's a broadcast. Text is more pinpoint, right? Queue is more pinpoint. Broadcast is notification is more broadcast. Remember these things. We will use it later on. Those ideology, right? So key takeaways: decoupling services in modern application development. Reliability and resilience are important, right? Because if let's say tomorrow Google goes down, you know that even if they goes down for a minute, that's very going to be very bad for them, right? Their stock will lose millions for in 1 minute. Resilience is important, right? No matter how much like traffic they get, they should be able to stand it. One effective way to achieve this is by adopting a service oriented approach. Monolithic applications, right? Monolithic applications are application consist of multiple components that work together to transmit data, fulfill requests, and keep the application running smoothly. In a traditional approach, the application architecture, the components such as database logic, web application servers, user interfaces, and business logic are tightly coupled. Now, tightly coupled, what it means is when you might have seen this is actually where everybody starts, right? Coding. When you start coding, how your architecture is, how are your files stored? When you start, right? Let's say this is your folder, or this is itself your folder, right? This is your folder, let's say coding. You put one file, print hello world, right? Let's say print hello world. Then in the same area, you have another file, let's say test a tic tac toe game, test tic tac toe game, and let's say with the tic tac toe game, you have made you are calling another function from here to, let's say, play chess, something, right? Displaying stuff. Now what happens is all the files are very much hodgepodge. They all are together and things depend on each other somehow, right? Let's say print hello world, printing part is dependent on test tic tac toe game is dependent on print hello world, chess is dependent on tic tac toe, which again depends on hello world, right? All are very much dependent on each other. That's tightly coupled, tightly dependent, right? That's a monolithic architecture where all the files, all the stuff, right? Like all the application, your right, is in one folder, your app folder, right? And you will see here the back end, you will see here the front end, you will see here like various setup files, you will see here config files, a bunch of things like that. That's what tightly coupled looks like. One second, lads. Apologies. Okay. So all are very much together and all, right, are using each other's stuff, right? All are using, let's say, setup front end is also using the same configuration file as the back end. They are using the same setup files as the other one, right? So they are tightly coupled. Everything is kind of dependent. Backend is very much dependent on some functions here, right? Libraries here. Now, that's what they are talking about. Is that in a traditional approach, and this was the old approach, doesn't mean it's bad. Doesn't mean it's bad, just means that it was old and things were tightly coupled because software engineering, the way they did it, it made sense for them, right? So approach to application architecture and components such as database logic, web application servers, user interfaces, and business logic are tightly coupled. This means that if one component fails, it can cause the failure of other components, potentially bringing down the entire application. Yes, that's one big issue with monolithic, that if, because everything is dependent on each other, if one fails, all will go down, right? Overall, that's true. But because in real world, what happens is we don't have just one application, we have the same copy pasted version of these all the things, right? Let me make this smaller. What we do, we create like multiple folders, we create multiple servers, and all are same, right? So even if one server goes down, there will be others, right? And that's kind of true that if one part goes down, the whole entire application goes down. One second, lads, give me 1 second. Hello, everyone. Okay, back. So if one thing goes down, all other goes down. That's true, right? What happens? What's a different approach to it so we can make such that if one goes down, not everything goes down? You guys can hear me, right? Hello, hello, hello. Yeah. Okay. So what we can do if instead of one thing go like if let's say one thing goes down, there is okay, awesome. So if one thing there is issue with one, right? So that others don't have issue, then we come up with instead of monolithic, we have something called microservices, which is very popular nowadays. But just because it's popular doesn't mean it's great. Hitler is very popular, doesn't mean it's a good thing, right? Jeffrey Epstein is popular, doesn't mean it's a good thing. But this one is also popular. It can be good or bad depending on what you are facing. So that's true, man. That's true, right? Okay. So what happens in like in monolithic, we have one server with all the apps together, another server with all the apps together. In microservices, let's say what we do is we create one server, right? For let's say database, we create another server, and we create another one and another one. So what we do, we create another one for front end, we create another one for back end, and we create another one for let's say handling like some business logic, whatever. Or let's say we have like some Nginx for web traffic, handling traffic, right? Networking stuff. So what happens with this? Every single one of them is a different server. So if one goes down, because front end configuration files does not affect the configuration file of database, backend and stuff, these all are still there. And if front end goes down, there is an error. Only the front end can come. Front end needs to come back. Important part here is understand, right? This code, the total code is let's say 4 GB for all these four things, right? So if one goes down, 4 GB amount of database code comes back up running, which includes the backend has to restart, the setup configuration has to restart, the database has to restart, and the front end has to restart, right? 4 GB code has to restart, which you can assume now you can understand it will take time. But in this case, let's say all were 1 GB amount of code, right? 1 GB, 1 GB, 1 GB. Only this has to come up, restart. This server has to restart. It will be way faster, right? Not just 4 times faster, maybe 10 times faster, right? Because only one thing has to go down. Only one thing went down. So that's the beauty of microservices architecture. Important to understand why this is very important, right? To understand why I'm such a big advocate of like monolithic is not that bad still compared to microservices is the I think the best answer I will give you is there are two applications you might have heard of, two real world applications. One is Amazon Prime, second is Netflix, right? Both provide the same services, but one is monolithic, other is microservices. So, and there is a really good Fireship video, right? But also there is a really good article by why Amazon Prime is monolithic, but Netflix is microservices. Why Amazon Prime reverted to, and this was like a year or two ago. This I think more than a year ago, but I don't know why that just this article might came. So yeah, microservices to Mota the 3 years ago, right? Very important to understand why. Biggest reason is because this now when a data right now this will actually make you a better programmer right here. When something was coming, a traffic HTTP request was coming, right? Inside one code only, it was tiered out, right? It was like all the HTTPS, everything, just the main request came and everything was passed on easily. There was no overhead. But when, and this is something I will give you a good example too, but when it comes to, let's say, front end, or let's say the traffic comes here, it has to go here, then it has to go here, there is some networking happening, then it is going here, then it's looking here. There's so many extra stuff happening. That's called overhead. And when the overhead is more, as you can imagine, all these these services like Netflix and Amazon Prime, all are inside cloud. So this extra overhead, right, cost money. This is network input output. And in cloud, if you remember when I taught in the start, I said even breathing in cloud takes money. We have reached, if you breathe, you will have to pay money. That's how cloud is, right? So a real world example, remember this to understand difference between monolithic versus this. Let's say you live, let's say this is like a joint family. That's good, right? Yeah. So thank you. That's good. You understood. I'll just give you a very quick example then. This is nuclear family. Joint family, right? If somebody comes inside your house, a guest comes, all can sit on one table, right? All can sit around one table and meet and get things done within 1 hour, right? Met everyone, got things done, good job. Now a guest comes here, right? First they have to meet, like, let's say grandparents, talk to them. Then they have to meet, like, let's say the parents, your parents, right? Then they have to meet you. You understand, there's like overhead. It takes time for the same thing which could be done. That's how the monolithic. So there is like important to understand that just because cloud says a company like Amazon, no matter how good it is of a company, just because it is saying, oh, this is a better architecture than this, does not does not mean that it will work for you. right? That's important to understand because Amazon Prime and Netflix both use AWS services, but one is a monolithic, one is microservices, right? So have a look into this and try to understand why this is the case and how much money Amazon Prime, it actually, Amazon Prime saved infrastructure cost up to 90% when they switched from microservices to monolithic. 90 freaking percent. Imagine how big of a saving for Amazon Prime if they were spending $100 million on Amazon Web Services. Now they are spending only 10 million. That's like 900 million, $90 million of savings. Heck yeah, right? So that's why it's important to read, and like there are some really good dev too, right? There are some really good like those um, extensions that help you with those. Yeah, yeah. Well, which is a whole different case. If you want to understand why Netflix is the king of movies and series, now I when I go for walk, this is what I look at. Business Wars is a free podcast. Put it in your headphones, go for a walk, and you will see what is and why it is like this. Right? A very good series. Right? Netflix versus Blockbuster Business Wars. It's like 5 episodes. Every single one is very detailed. Have a look at it. It's beautiful. The whole history is freaking beautiful. It's just unfortunate we are being taught history by the most uninterested people. But it was beautiful. That's right. There was business and technology beauty with Netflix versus Blockbuster, lads. Okay, going back, right? So the design promotes greater flexibility and reliability, yes, but if I can like save 90%, right, and if my let's say my stock goes down by like only 5%, but I'm the 5% means 5 million, but I'm saving 90%, it will go back up anyways, right? So understand these technology, see what makes sense, and then pick. So supporting and scalable and reliable cloud communication, Amazon Event Bridge, SNS, right, the notification one, SQS are the AWS services that help different parts of an application communicate efficiently in the cloud. These services support building event-driven and message-based systems. Together, they help create scalable, reliable applications that handle high traffic and can enhance communication between components. Right? So, what they are saying is, remember we were talking about this. Let me make this a little bit more clear. Now, now we were talking about this, right? Database, front end, all are communicating with each other. How they are communicating? That's what Amazon Web Services comes into play, like Event Bridge and all these. That Event Bridge is a serverless service that helps connect different parts of an application, like front end, back end, right, and other ones, helping to build scalable event-driven systems, right? So if let's say the what's this called? Let's say a bunch of people start, like if this is Netflix and a bunch of people like start like your startup goes like boom, right? Like it just gets a lot of traffic. Now I don't have to have multiple databases, but I do need like multiple front end servers because there's like so many people using my front end application, and same with backend. I want the processing to happen fast. Now if there are two backends and two front ends, how you are going to like which front end will talk to which backend? Now that's where something like SNS comes, where it is like treats this as a group, and all like other event services come where an event happened where you created two front ends and two back ends. And now this communication is taken care by AWS services, right? So with EventBridge, you route events from source like custom apps, Amazon Web Services, and third-party software to other applications. So you're from your custom app, front-end custom app, to your back-end custom app, right? EventBridge simplifies the process of receiving, filtering, transforming, and delivering events so you can quickly build reliable application. An event happened was, oh, a lot of traffic is coming, right? Too much traffic is coming. We need to start more front-end servers, more back-end servers. AWS services, in this case, EventBridge, will help with that communication. Example of EventBridge: customers use an online food delivery service to order meals from a local restaurant through a mobile app, just like you have seen Skip the Dishes or Zomato, right? Food delivery service to order apps from local restaurants. When a customer places an order, several steps are needed to help to happen simultaneously. To learn more about these steps, choose one of them. So first is like when you order, your payment is processing, right? Next is resource restaurant gets the notification. Your range, what's up? Then inventory management, right? They see if that even works or like how much to give out, or they if they it's already prepared, the naan is already prepared or not. Did I? Oh, apologies, lads. My bad, my bad. That's legit my bad. I'm so sorry, man. I'll just update it right now. Thank you. I was thinking for a second, why did he? Thank you, man. Thank you. Thank you. You made me explain. Sorry, man. Okay, going back, right? We have delivery dispatch. A delivery notification goes, right, and a delivery. So many moving steps are there when a single order is done. That's where we have something like EventBridge that communicates with different. So it will first, the application will use EventBridge and say, okay, process the payment. That is done. EventBridge will give it back, right? So here's the process. App, another app comes with payment processing. It gets back, then it will do the order to the restaurant. That's really big. Restaurant will get the order. Yes, it got the order, right? And then it would be like, okay, order is like being made and then shipped. Like now the driver will get the notification that, okay, pick up the order, go here, right? Moving parts, and event bridge is this bridge between everything. This, 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 all these things. How EventBridge helps? EventBridge can route events like order placed or payment completed to the relevant services, right? Payment, restaurant, inventory, and delivery. It can handle high volumes of events. So a billion people wants to order at one point. It can handle, making sure each service works independently. Even if one service fails, EventBridge will store the event and process it as soon as the service becomes available. So EventBridge is like a queue, right? Why is a queue? Remember we were talking about the bus stop, right? In bus stop, what happens? You don't show me respect, no need to show him respect, right? So three people are waiting here for the bus. And bus only allows, let's say, two people. There is only a limit for two people, right? They both went in. What happens to the third person, right? What happens to this little guy here? He waits for the next bus. Same idea here, right? Event bridge will store the event. If one service fail, event bridge will store that event, right? Now remove the event with the app, and people with the events. Yeah, not in India, bro. Not like this is not India, right? So the app, let's say, is gone, it's not there. Event will wait till the app is again available. Event Bridge helps provide a smooth, reliable operation across the entire system. Now, another thing they mentioned, which I want to talk about, is Event Bridge is a serverless service. Serverless is the worst word chosen, but what, because it doesn't put the point across. What serverless means is that you do not maintain the server, no maintenance. For example, you might have seen when you are using YouTube, are you maintaining the YouTube server? No, you are just using YouTube's video streaming service. When you're using Outlook, are you like taking care of the SMTP servers? No, you're just using the app. Same thing with this. When you are using a serverless application, that means you are not maintaining the server or the code. You are just using the app. That's a simplest definition of a serverless service. Okay. Don't worry, it still runs on a server, you just don't maintain it. SQS, that's the name itself has queue in it, is a messaging queue service that facilitates reliable communication between software components. It can send, store, receive messages at scale, making sure messages are not lost and that other services don't need to be available for processing. In SQS, an application replaces messages into a queue, places messages into a queue, just like the thing we were talking about, the bus stop case, and a user or service retrieves the messages, processes it, and then removes it from the queue. The bus takes the person, right? He travels in the bus and gets out. Same thing. Uh, App takes the message, process whatever the request was, and then takes the next one, right? Removes it from the queue, takes the next one. Example for that, and there one thing you will notice that every single, if you see a high level reading of these, right, event serverless architecture, they're same as like, okay, custom apps, build these, all are this is happening. They are very similar in a lot of ways, just by little ups and down. There is a little bit up and down in between these services, but there is a lot of overlapping. There will be like 90% overlapping with some of them. You have to still, like, that's where a solutions architect's job comes in, to pick the right one for right choice. As customer support teams grows and the volume of issues increase, traditional workflow can struggle to keep up. Let's consider how customer support team can tackle this challenge. Scenario: a customer support team consists of support agent and technical specialist. The support agent is responsible for receiving customer issues, and technical specialist works on resolving them. This process works well as long as both the agent and specialist are available and coordinated. Customer submits an issue, support ticket assigned to the technical specialist, the tech guy works on it. Pretty simple. Challenges: what happens if the support agent creates a ticket, but the tech guy is working on another one, right? He's busy. The agent would have to wait for the tech guy to be free, and there will be dissolves solving this. As volume of customer issue increases, we need more tech guys. Or what we can do, instead of like calling them, hey, these are the stuff, what we can do, hey, this is the ticket I assigned to you. Whenever you're done with the current task, take from here. Pretty simple. Like, there's no much brain power required in this one, so you should be good, right? Same as like, okay, I have 10 different homeworks to do. I will do this one, then I will take the next one. I can't do 10 different at same time, right? So next is the notification, SNS. First one was queue. This is the notification. SNS is a publish, subscribe, pub sub service that webhook. What do you mean by webhook? Service that publisher uses to send messages to subscribers through SNS topics. In SNS, subscribers can include web servers, email addresses, Lambda function, and various other endpoints. You will learn about Lambda in later details. So, what this means is pretty simple. Publish, subscribe, right? Where do you see subscribe? On YouTube. You subscribe to my channel, right? You will get a notification. Same thing in this case. In this service, let's say you subscribe, right? SNS is subscribed to a topic, right? Or topic is, let's say, an event or anything, right? Which changes. So topic could be, let's say, you a Gaurav went online. That could still be like a censored hacker went online, or it could be, let's say, um, Trump did another tweet, or weather increased by 20 degrees in 1 week. Stuff like that, right? It could be any topic. Okay, whatever is the topic, based on that, if something happens, right, you want either the notification or you want something to be triggered. Somebody pushed the latest code to the branch, right? You want the whole thing to be built, like the new server, the dev server to be built. This notification is given to that server that, hey, rebuild again. Kind of like webhooks, I mean, automatically send data to another application, then event happens. Yes, exactly. Like an event occurs, right? If that has subscribed to it, it will send that notification and trigger another event or send you a notification. Rover, what's up, dude? And there is Lambda functions, which we will talk about them later. But basically, these are Python codes or like any type of code which you don't have to create a server for. These are serverless, right? We'll talk about that. I will show you Lambda is, right? Don't worry about it. Just some code. Also, lads, Saturday night, my Saturday night, your Sunday morning, coming online, I will have short glasses and the sriracha for 10. No, you guys are crazy people. 20,000 points on Twitch. You guys can give me, you can make me like take one shot. Okay? Enjoy. Happy weekend. Happy weekend. Same to my a-hole. Enjoy. Example, Amazon SNS. A company that sells a variety of products is currently sending a single email to all customers with updates on various topics, such as new products, special offers, and upcoming events. Although this method worked in Rover, can you send a message to everyone? Saturday stream, this would be the case. Please and thank you. Although this method worked initially, customers want to receive only updates they are interested in. The current email update is causing customer dissatisfaction and lower engagement. Oh, congratulations. Congratulations. Don't worry. You will get that too, bro. So current email update is making customers unhappy because if somebody wants to know only about the new products, not special offers and upcoming events, spam, right? To learn more about the solution, choose one of each one of these, right? Segment the communication. So what is saying? Okay, based on different events, new product, create a separate topic. Event, create a separate topic for it. Stuff like that, right? The company decides to divide the communication to three separate topics: one about product, one about offers, one about events. Each topic focus on what people have liked in the past. They only those they will get. Like, so if I liked new products, Wrench liked events, Rover liked offers, they all will get only, I will get about products only, not them. Less customers choose the topic, pretty simple. They subscribe to that topic, right? So there are 10 different YouTube channels you have subscribed to, but you only got notification from one or two of these. You only get notification from those. Send tailored notification. A company can send personalized notification to subscribers where you can have like hi and then per customer name, right? Amazon SNS makes sure that these notifications are promptly delivered to the right audience, right? They take care of it. So the what best describe the key difference between tightly coupled and loosely coupled architecture? In a tightly coupled architecture, components are tightly connected and dependent on each other, whereas in a loosely coupled, components can operate independently. Yeah, seems good. Tightly coupled systems are more flexible in adding new components, eh, whereas loosely coupled require careful configuration. No. Tightly coupled architecture are designed for scalability. Uh, Not exactly. No, no. Whereas loosely coupled are for high availability. They both are availability good, but like they depends. Loosely coupled systems require components to share data directly to each other, whereas tightly coupled store data in central repository. Um, so best difference, right? The best description of these two, I will say is this. Some of them are true in somewhat sense, but when we comes to like the best, this is going to be the case. Now, lads, this is what you have to answer. In a banking system, when customers transfer money, the transaction details are sent from the transaction service to a fraud detection service for verification. Sometimes the fraud detection service is temporarily down. What is the main advantage of SQS, Amazon SQS, in the banking this scenario? It guarantees immediate approval of transaction. It stores transaction details until the fraud detection service can process them, even if service is down. It speeds up transaction processing by avoiding use of buffer. It stores the transaction service and fraud detection service to depend on each other directly. What is the best answer for this, lads? Come on. Want to hear some good things? Gimme, gimme, gimme. Gimme, gimme. Oi, gimme, gimme. Come on, you have 10 seconds. I want to hear because remember, if you do it right, wrong, that's how we improve, right? Try to answer if something is you think is right, why it is right. If something is wrong, why it is wrong. The question is, let's say a bank, right? A bank, whenever a customer transfers some money, let's say I'm sending money to you. Transaction details are sent to a fraud detection service, right? And what is the benefit of having SQS if the fraud detection service is down? It stores transaction until fraud detection. That's actually correct. Yep. Good job. Now let's do the assessment and get module 2 done, a very big one, right? 80% or higher. Let's go. A startup company is building a new web application and chooses general purpose EC2 instance to host application. Why did they choose the instance type? Is it specially designed for memory intensive application, which is ideal for hosting web app? It provides a balanced mix of compute, memory, and networking resources while keeping costs effective as they scale their use base. Is it designed for high storage capacity, which is needed to host large databases? It provides highest performance for compute heavy tasks such as video rendering and machine learning. So, lads, what would be the right answer if a new web app is made and it uses general purpose EC2 instance? Beautiful. Yes. Yes. Because there are specific one for high storage. There are one for compute heavy, right, with GPUs, memory intensive, but a general one starting from T are actually compute for things. Now let me ask you a question. Why they started with this, nothing, not other one? What could be the reason they started with the general purpose one, but not, let's say, high intensity or high stuff like that? What could be the reason, lads? Robert said, "Hi, nice." Think about it, lads. Why they if you start a web application, why you would go with general purpose, nothing else? I'll give you 10 seconds. Okay, let me explain why general versus others. They don't know what application needs more, or like they are unsure about the web application. Yes, sir. 5 a.m. quiz time. Welcome to student life. But a lot of companies choose this well balanced one because they are not sure. Biggest reason is you're not sure. Or yeah, web application, nothing like specific. Web application, it could be YouTube where you need high. It could be a gaming one. But right now, in this case, they are not sure, so they are okay with the general one, and they can change later. Now, a software development company needs to notify the engineering team whenever a new bug is reported in their bug tracking system. Some team members need to be notified immediately, whereas others can process the bug reports later. Two types of people: one needs to be notified immediately, others later. Which service would the software development team choose based on the requirement? Elastic Load Balancer, Simple Queue Service, Notification Service, or EC2? Which one and why? You got 10 seconds, lads. Remember, they want to send some type of like a message to the team. Only few people. That's my first question. Which one? Why? And how? Next question would be now. Okay, if if SNS, how they will do it? What the team one will do versus team two? What would be the difference? How like one team will get the messages, others will like not. I'm making now an NA with vector database using AI in the middle, so it will fetch. Yeah, why not? You must be using ChromaDB. That's a good one. Or you using something else? And you using LangChain? Anything LangChain related or just NA10s pure? But let's focus on this. Shira, what do you think? What would be the way they like the one team will get it and one not? 10 seconds last. Okay, let me answer. Okay, sounds good. Quadrant. Yes. So team A, the one that's getting notification, will subscribe to that topic. Team B will not. That's correct. Dude, you should take like the exam, man. You will be like, oh gee, you will be in a very good position. How does Amazon EC2 auto scaling work in AWS? Amazon EC2 auto scaling adjusts the instance type but does not change the number of instances. Amazon EC2 auto scaling requires manual intervention to add or remove instances based on traffic. Amazon EC2 auto scaling automatically adds and removes instances based on performance data and application metrics. Auto scaling adds instances when workload is too high, but it does not scale down when demand decreases. Okay, so three. Let me ask you now question, a follow up. Tell me the difference. Tell me what is wrong with the first, second, and fourth. Then, if you are saying three, what is the wrong with first, second, and three? Sriram, this is actually from yesterday's topic. EC2 is basically Amazon's virtual server, right? You can start up a server, and there is a extra another service called auto scaling, which comes with EC2. that let's say if a traffic goes up, it does change our turnover, but not manually, for it does go both ways. Yes, beautiful. So what I was explaining with auto scale, let's say you are like a something like a YouTube, right? Company, right? You have one server and it can easily like handle 100 users. But now all of a sudden, like Instagram or YouTube, your social media became viral and it is getting thousands of stuff, right? What auto scaling will do, it won't wait for you, right? It will automatically, when the um, traffic goes to this, it will automatically start new servers and takes care of all the networking and everything. You don't have to worry even a bit, everything will be smooth. Now, when let's say from 10,000 it goes to 1,000, it will remove the servers that are not required and have enough that things can be done. That's EC2 auto scaling. And Rover, awesome. Good job. Now, fourth, a company has critical steady state workloads and batch jobs that are not time sensitive. How should they optimize cost using EC2 savings plan and spot instance? Critical steady state workloads and batch jobs are not time sensitive. Use spot instance for all workloads to maximize savings and avoid savings plan. Use savings plan for critical workloads and spot instances for bad jobs that are not time sensitive to maximize saving. Use saving for all workloads, avoid spot instance because of interruption risk. Use savings plan for non time sensitive and spot for critical jobs. What is the answer, lads? I know you got this. It's a very easy one. I don't want even to ask like for a follow up on this because it's very easy. 10 seconds. And Sriram, I will explain to you spot instances, don't worry, and savings plan. No answers? Lads. Okay. Answer would be second one. Why? I will explain. Now, Sriram, let me ask you this. Pretty simply, right? When you say, when you go to, let's say, a service person, right? Somebody who is like, let's say, as a gym, right? When you go to a gym, either you can pay, let's say, monthly, or you can say, hey, you know what? I'm going to come for the whole year. I want a discount. So if you subscribe for yearly, you get, let's say, 20% discount, right? Same case with AWS. AWS, you can pay monthly or pay as demand, right? But you won't get any discount. But if you say, hey, I'm going to use for the whole year this much, right? And I'm going to pay you, you can get a discount. That's saving plan. Spot instances, let's say there's a server, right? And right now the server, like when it's used, right, it uses 100% of it. But there are times when the server is only like being used, like for example, um, Amazon shopping, right? During the daytime, usage is let's say 90%. Pretty big number, right? Server can't add anything else. But let's say at night time, when usage goes to like let's say 40%, because at night nobody shops, right? There is still this room here which is not being used. So what spot instance does is that this extra room, they tell the customer, hey, what if we give this extra room to somebody else, right? Because you're not using. If you need, you will get it back till you don't need it, and if somebody else use, will pay you. That's what Amazon does. It's one of their offerings, and this is called spot instance. Now, batch processes, because they are not time intensive or sensitive, and they are not critical, it's okay to run in spot instance. If there is taken, that doesn't matter. It will You will get it back eventually, and you can run them, right? But for the other one, it's critical, and you need it. You 100% need it. You cannot afford not going to gym. That's when you use this. I'd add, what happens if one component fails in a loosely coupled architecture? Loosely coupled means things are separate, microservices. What happens when one of them fails? The system can continue to function as other components are independent. The system automatically switches to a backup component without any intervention. A failure causes the entire system to fail. Other components must manually be restarted. What would be the case, lads? System can continue to function as other components. What happens if one component, let's see, loosely coupled systems are designed so that components are independent. If the component fails, the rest of the system can continue function manually, right? Case is, why not this? Why second option is wrong? No. Thing is like, okay, it so automatically switches. Does not necessarily mean there will be a backup running, right? Main idea is, what happens if one component fails? All others keep on going. Only a new backup will come if you have it in place, if you have that code in place that, hey, if something fails, turn it back on. But in loosely coupled, this will always be true. This may or may not be, but this will always be true. They're like these things I'm saying are like pretty stupid, like things to say, very trivial, but that's how it works in these entry level exams, man. Like these low level exams, they play with you like this. Which option best describes how compute resources are provisioned and managed in cloud? Resources must be pre-purchased and installed on site. So basically, what describes cloud best? Resources are provisioned based on demand, and allow for scaling and management. Computer resources are fixed and cannot be scaled. Computer resources require constant manual management. Alrighty, 10 seconds. I think I filed for this one. I will just go with like I think answer I know. You want me to go ahead? It's on demand. You can scale to however big. Netflix works on Amazon web services. So something like this, I will just answer myself. A marketing agency, this you will have to answer. A marketing agency is developing a new web app, expects steady growth, but is unsure of traffic in early months. They want flexibility without a long term commitment. No long term commitment. Unsure of the traffic, right? Steady growth. What pricing option should they choose? Spot instance, savings plan, reserved instance, on demand. Why? And please answer. Why this and why not other, maybe? You have, let's say, I will give 15 seconds for this one. This is a good question. This is a good question. Why not this? Why that? Right? Why spot instance? Why not savings plan, or why not reserved or on demand? Why spot instance, boss? Okay. Okay, eh, let me answer it in let me take one at a time, and then I will answer for every single one of them. Okay. So spot instance is when, let's say you want to run a task that you are okay if it's taken, like this resource, the server you are using, right? Spot instances, there are two people in spot instance, right? Let's go back here. Now understand this, Sriram. I think that I didn't explain to you properly this thing, so apologies from my side. Spot instance is when there is unused resources on somebody else's server and you want to use it, right? So it is like, hey, I want to rent at your house till you have the space. Once somebody else is coming from your family, I will get out. So, in this case, you want a reliable server. You want a reliable place. Would you choose spot instance? Would you go on rent if you want like a spot instance type rent? Um, if you want like a reliable place to sleep in, right? So spot instances, when you are going to take sleep in somebody else's house, not the other way around, right? When they are talking about. So do you think this would be the case now? You are developing a web application. There is steady growth, so you need to be available all the time, right? They are just not sure of the traffic, but they need to be available. So spot instance won't work because they can't allow that if their agency is not website is not working, right? So not spot instance. Savings plan, we talked about no long term commitment. So saving plan is about 1 or 3 year long commitment. Reserved instance, they are not sure of the traffic in early months. They are not sure. It could be one person or 10,000 people, right? So best would be on demand. Yes, because if there is 10,000 people, all of a sudden they can spin up, right, on demand. If there is one person, they can go down, up and down, up and down, up and down. Hopefully that makes sense. Sorry, I don't think I explained, and I think you might be thinking of this as spot instance, this person, which is wrong on my part. This is spot instance, the person who is going into somebody else's house. Okay. Now let's look at a media company is working on a project that involves rendering complex visual effects and simulations. The rendering process requires significant. Awesome. So a media company working on project that requires rendering complex. So Marvel Studios, right, working rendering require visual effects, right? Avengers and stuff. Rendering process requires significant computational power and hardware acceleration to handle intense workload. Compute heavy, 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 right? Super, so much. It requires GPU, CPU, blah, blah, blah. What EC2 instance type is best? When there is a lot of significant computational power required. Memory optimized, general purpose, accelerated computing, compute optimized. Do you guys want a difference between accelerated computing and compute optimized or no? Or can you answer? I'll give you 10 seconds, lads. I'll give you 10 seconds. And try to explain accelerated versus compute optimized. Templar, what's up, dude? How you doing? Long time no see, bro. How you doing, boss? That white t-shirt is like, yep, yep, that's why I like it. Dolla, bro, dolla. Okay, 10 seconds are over. Let me explain to you guys. Easy to instance type. Memory optimized is when the RAM is a lot, when you need a lot of RAM, your network input output is fine, right? Your CPU is fine, but your memory you require a lot. So not this case because we need computational a lot, not memory. And I actually was thinking of doing a project, but like in silence. I will tell you what project I was thinking. We'll talk about that later, but like this is memory optimized. General purpose. No, because we need computational heavy, right? This general purpose is like a laptop. It will have everything, but it cannot like render big AI stuff, right? Accelerated computing and compute optimized. These are very nearby term, right? Accelerated computing, if I actually go, right, this is like something if you look. Accelerated computing for hardware acceleration and co-processors. This is AI level stuff. This is about, let's say, how to say it? Like this is when you need like those CUDA, 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 CUDA cores, right? Like CUDA cores, right? For like training your LLM, accelerate, right? Graphics processing your games and stuff. Now, but compute heavy are computationally heavy, good for those workloads we are talking about. Accelerated computing is about AI. Let me put it this way. Hardware acceleration. Hardware acceleration, where do you see? In NVIDIA. NVIDIA launch, like I can check, okay, which programs do I want like performance hardware accelerated or not? Must be somewhere. Do I want CUDA GPUs, right? Do I want it to be there so it can render? And I can explain to you why, what is accelerated computing, but basically understand these. There are, this is for AI and stuff. What they are asking is for complex visual effects and simulation. So that's compute optimized. No? Okay, my bad. That also works with, go back. Go back. I was wrong. I still believe. Compute bound high performance processors, example workloads are batch processing, media trans. They didn't talk about media. Perform floating point graphic processing and data pattern matching. Okay, we'll talk about that later. Okay. Okay, we'll talk about this in a bit. Now let's look at the next one. How do Amazon EC2 autoscaling and elastic load balancer work together? This one I want the answer because I explained very well. They operate independently and not connected. Amazon EC2 autoscaling handles traffic routing, whereas elastic load balancer manages instance scaling. Amazon autoscaling adjusts the number of instances, whereas ELB distributes traffic evenly across them. ELB automatically scales EC2 instances, and EC2 autoscaling adjusts the traffic. Lads, I want the answer for this. I want the answer for this. 10 seconds. Okay. So, what happens is you have, let's say, one server, right? Right? And it's getting traffic through load balancer from the internet. Internet hits the load balancer and it hits your stuff. Number five, what do you mean five? Right? It hits the load balancer and there's one server. Now your Instagram, your social media pops up and it's getting a lot of traffic. What load balancer will do is it will tell auto scaling, hey, I'm getting lot of traffic, and your server is, let's say, we created a rule that as soon as the server fills up 80%, create another server. And elastic load balancer will say, okay, your server is almost reaching 80% and we are getting more traffic. It will start another server. Auto scaling will start another server. Elastic load balancer will say, okay, we are getting so much traffic. You're almost like filled. So load balancer job is to like distribute traffic evenly across. Now there are two servers. It will make sure both of them are getting traffic and it reaches from 50 to, let's say, 80 to, let's say, 50-50. 50% distributed there, 50 here. So let's say it would be 40% here, right? Instead of 80 on one. Load balancer will send traffic to different servers. Auto scaling will increase. Mukesh, what's up, bro? Dude, I will like in half an hour, in like 15-20 minutes, I will. Four more questions and we are good to go. Five more questions, we are good to go. What is the primary role of Amazon machine image when scaling applications? What is the role of having that image which we talked about, just like we have for Kali, right? Kali VirtualBox image, we have these images, right? What is the benefit of having a similar image of your server in cloud? It automatically manages network traffic, store backup copies of application data, configures scaling policies for application, provides consistent image to launch a new instance. Lads, come on, give me answer. 10 seconds. If you don't answer, you won't know if you were wrong or right. It's great to answer, right? You will know, okay, if there was some misunderstanding and I'm here to help. I learned that, okay, I gave it wrong. I'm going to read about it, right? I made one mistake. Okay, so give your answer. I will answer this one. First, it does not manage its traffic. It's not a load balancer. No, no. I will tell you this. Amazon machine image is like a virtual box image when we download or when we are playing with, our virtual box. Machine image is like one of those images, ISO type images, so we can create more virtual machines, right? Gotcha. No problem, bro. I got you. Scaling policies are again load balancer type stuff, right? Those are configuration related things. Policies, configuration related thing, nothing to do with the image. Multiple choice testing is cheating. Take the keyword from each answer, match it to the topic. Yeah. But this one we need 80% right, bro. To pass, we need 80% right. Backup copies of application data. You take it, it goes in the backup vault. You create a snapshot. Snapshot means backup in AWS. But machine image is to create new instances. When we were talking about here, right? One and second server, where the second server came from, how the auto scaling thing knows where to create the new server, how the new server will look, right? Machine image. Bro, why does the virtual box of Windows look like Kali one? What? I didn't get it. Virtual box for Windows look like Kali one. What? I didn't get that, was sorry. Can you explain? Can you reword it? Rephrase it? We'll move to the next question till then. A manufacturing company is running a set of predictable is important word, workloads for next 3 years. Another second one. And wants to optimize the cost, reduce the cost. What are the best plans? Answer, lads. The UI for the VirtualWorks you opened looks like Linux one. Oh, it could be same because like this is like by Oracle itself, right? So they could like design it that way. Yeah, I didn't do anything. So that's how they designed it. Yeah, they are made by the same company. All are by Oracle. Oracle owns VirtualBox now. They bought VirtualBox. So it's like downloading GTA Vice City or any of the games, right? You download GTA Vice City. There is actually a place called DOS Zone. I looked at. You can play GTA Vice City here for free. But nevertheless, so what happens is because the GTA Vice City, right? That game you are playing or you're playing any other game is same. It's by the same company, so it will look same on all the different ones, whether it's with Linux, Windows, or Mac. Same company. Like for example, Outlook, right? It looks same because Microsoft. Chrome browser, same thing. Okay, let's answer this. Reserved instance, on demand, spot instance, dedicated host. Predictable workloads for the next 3 years and want to optimize the cost. Hello, Wrench Pie. So, answer would be on demand. It cannot be on demand, right? Because we have 3 year commitment we can give. Spot instance, we need. It's important. It's predictable. They're not saying it's batch. Dedicated host is like when you are getting a whole server dedicated to you. It can save money, yes, but let's see reserved instance cost savings. Reserved instance is one of those words which you will see with savings plan, where the discount you receive when you commit of using. You are reserving an instance. It's like, hey, I'm going to reserve. Like I promise I will use this much for, or like let's say when you're going for rent, instead of monthly, you say I'm reserving this place for 3 years. Give me a discount. I want to reserve this renting place. That's what it is like. Dedicated host is good when you have really big ones, but not sure about like discounts you get or not. Which tool can be used to interact with AWS services through a graphical user interface? EC2, software development toolkit, command line, or management console? Thank you. I think I have not lost weight. Actually, the t-shirt is pretty good. I think I've become fatter, unfortunately. But it's okay. We'll do better. Thank you, Panda. Thank you. What's up, Panda? Long time no see to you too, bro. Nah, dude, I haven't gone to gym. I just go for walk though every day. A university research team is running climate modeling simulation that require substantial CPU power to process complex algorithms and analyze large data sets. Yeah, I need to go to gym. We did talk to, we saw like other in the other ways like with Discord and stuff, but not YouTube. Yes, I will. I will. So client modeling requires complex algorithms, a substantial CPU power, so a lot of compute heavy and large data sets. Why are compute optimized EC2 instance ideal for this task? They provide high storage throughput, making them ideal for tasks that require fast data retrieval and storage to large data sets. Optimized for handling tasks that require hardware accelerator. Accelerator type requires hardware accelerator, so not this. They are ideal for tasks that require significant GPU power to perform computational. Yes. They are designed for workloads that require a high amount of memory to process large data sets. Memory optimized? No, they are compute optimized. So it's choosing between this and this. Now, understand, large data sets was also talked about. Sounds good. All have a good night's sleep, boss. Night night. So, fast retrieval and storage of large data sets. I'll go with this. Wrong. Okay. Although compute optimized instances offer high CPU, they are not specifically tailored for storage intensive workloads. I thought they are talking about like a large data set talking to another service. My bad, I assumed that. Storage optimized instances can be better for such tasks. How does multi-tenancy refers in context to EC2? Lads, this is the last one. You guys answer this. Each EC2 instance running in its own private network. Instances are restricted to one geographical region. EC2 servers instances dedicated to an individual clients. Multiple users sharing same EC2 instance while maintaining isolation. Multi-tenancy refer to context of EC2. Number 5, 10 crore, 7 crore. You won, bro. You won. Private network, one geographical, no. Dedicated to individual client, yeah. Multiple users sharing same EC2 instance, no. I will go with this. What is the right one? Dedicated instances are separate, not a part of multi-tenant environment. I don't get this part then. Running its own private network. I don't get this part. Articulation, multiple users run isolated virtual machines on exact same one. Yes. I'm just going to use this. Multiple users sharing same EC2 instance while maintaining isolation. Okay, so same EC2 server type thing. Same server. Okay. I'm at 79. No, I'm not taking again. There are three EC2 categories serve different computing needs. Accelerated relies on GPUs, FPGAs for parallel tasks. Compute optimized high frequency CPUs for raw processing. HPC high density CPUs with ultra fast networking and large scale simulator. Okay, sure. Bro is flexing. Let's go. What the fuck, wrench? Good job, man. I need to do that too, man. I need to like start going to gym more. High performance. Okay, this is a supercomputer one. Huh. Okay, let me take it by myself. Let's see. Management console, steady workload, batches. Okay. I'm just going to answer all these, see if I can actually get it without like much brain power required. A-scale work. Thank you, bro. Thank you. Research team is running climate modeling simulation that require CPU power, not GPU, and large data sets. So I think large data sets is different, but I need to focus on CPU and what I have. They are optimized for handling tasks that require hardware acceleration. Hardware acceleration are S-rated ones, so no. S-rated type, right? Accelerated computing, but we are talking about compute optimized. So this is no. They're ideal for tasks that require significant CPU power to perform computational. Yes. High storage throughput. No. Designed for workloads that require a high amount of memory. No. Compute heavy workload for simulation offering. So large data set was a curveball. Startup company choose general. Balanced. Let's go. Loosely coupled. System automatically. No. The system can okay works independently. I'm flexing right now, lads. See, all will be good this time. Not using much brain power. That's every time works. Like when I overthink, I always like F up. Predictable workload for 3 years, reserved instance. Multi-tenancy refers in the context of EC2. I don't like the same EC2 instance word. It should be like same physical hardware that is their EC2 is running on. Refers to multiple tenants or users sharing the same instance but maintaining isolation. So that's like the same hardware but maintaining isolation. Media company rendering okay. Computational power hardware accelerator, so accelerated computing. AMI done. My brain like works when I don't think much. That's like this is one of those type of things. Recap and next step in this lesson you learned about compute, EC2, cloud sources, in auto scaling, blah blah blah. Right here is like a overview, lads. If you want, I can just share this. I can actually just print this and then share. I'll just share in the Discord with the whole thing. But yeah, we are done with this module. Tomorrow we will continue with the exploring compute services, where we'll talk about a very important one. There's serverless computing, which are like we don't have to maintain the server. Like you are using Outlook, you don't maintain the server. We have Lambda, container orchestration, and additional compute services. Okay, we'll talk about those. And this is actually very important. Containers and orchestration and Lambda both are very important. So we'll start with those. Let's see how much it will time it will take. Anybody want to play a game of chess before I go to bed? A 3-2-1. Lambda, container orchestration, this. Okay. We should be able to complete within 1 day. Hopefully. Or max 2. Anyone down to play a game of chess? Shriram, let's play with you. Let's play with you. My name is censored. Wrench, have you updated your engine though? Because I was able to like play with it, right? I was able to get it done. I was able to like trick it and win. So censored hacker is my name. Feel free to send it. I'll play with yours like maybe tomorrow. Maybe tomorrow. Let's play with Shriram today. Where is that? Mars taxpayer. Should I play a quick 2-1 game? Okay, here we go. Challenge 3-2. Let's go, boss. Let's go. Love the avatar. Okay, last game of the day, and then we'll go to bed. Come on, let's see it, bro. Aja. Okay. If I lose 16. If I win, I get nothing. Amazing. I love this game. What kind of bullshit is this? Even draw is like 8, -8. Shriram, it's your turn. Wait, why? Let's play. Let's play, bro. If not this wrench, then we can play one round, man. Not 10 minutes. Ah, okay. Let's play this one. Okay. Aja Shriram. Let's go, bro. Okay, that's a good move. Different. Thank you. Hmm. Let's see. Queen. I'm enjoying. You know, Wrench. You know this. You know this. Nice. Nice, 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 nice. I want to see how far things can go. Hmm. I'm not losing. I'm giving you. I'm giving you free piece. Let's go. Why not this? Okay. Now let's end this. My goal in next 5 moves. Let's get something. Okay. Now let's Wrench. Send me one. Send me a quick one. Yeah, I know. I'll accept this in just 5 seconds. Okay, wrench, let's go. A quick game. Should we do Saturday chess day? You too, mate. You too. I want to see maybe what is my review? It must be really bad. It's like 1,000, less than 1,000. 800, 600 something. Oh, it's 1,000. Jinx Script, what's up, dude? How you doing? Yep. You do cloud and pen. I do, yes. Yeah. We were doing cloud. We completed like module 2. We are at module 3. Before ending the stream, I wanted to like play some chess today. But yeah, cloud pen testing, and here's the Discord if you want to join. There's a lot of more folks with same interest. Why not? What the fuck? Fucking hell. Fuck, 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 fuck. Is your engine playing or is you playing? Come on. I'm down to play Among Us. I actually have even the paid version of it. Yeah. Fuck, no. Shit. Can't do this. I fucked up. I effed up at so many levels in this game. Okay, still one. Okay, thank God. I hate this game. Oh, but I'm down to play Among Us for. I am down to play. I have like with the Epic game. I think I have Among Us with it or Steam. One of those I have Among Us. Yeah, no, 100%. But it's part of the game. So I'm down to play Among Us whenever if you guys want like a weekend with chill and stuff. I'm down to play that. Wait, were you playing or your engine playing? That's what I want to know. It was the engine you would have lost by now. No, last time I won with the engine against the engine. Yeah, I will play with you again. I can play with you again tomorrow. Yeah, no, your chess skills are also weak. But I can play. One of my favorite, like I think, let's. I will give you this. DOS Zone. Look at this, lads. I also played one of my favorite games recently on this. Another one. You guys remember this? Yeah. No, that was just part of the game. That was just part of me making you lose. So you just think, oh, so easy game, you know? Yeah, I'm down for that. But you guys remember this? This game? Wolfenstein? Nah. Sensitivity is so high on this game. Dude, that was such a good game. Holy hell, sensitivity. Bro, sleep, you know you. I will not lose against you, boy. It's such a good game. I know there will be a motherfucker here too. I'm good at this game for sure. Yep, that's how it works. Bro, I love Contra too, man. Contra was best. Do you want to see if Contra is here? Taken 3-2. Yep. Check the site. Which one? Level 1 done, lads. Level 1 done. GG's. Okay, no more gaming. Just want to check one game. Then I will check the stuff, bro. Contra. Is Contra here? No, Contra Bridge, no. Contra C. C. Commando. Contra is not here. That's sad. We can find like other places where Contra. I know there will be Contra somewhere. Vixon. Okay, what you got, bro? We checked though. This one we checked, right, that day? You added something new? Did you added the game? No, what was it? Alt P, no. Check theme, okay. Dark, make me blind. Oh, okay, this is new. This is nice. Oh, nice, nice. Matrix, yes. That's what I wanted. Nice, bro. Good job. I love this. Good one. I love Matrix, man. This is such a cool effect. I love it. Cheers, bro. Cheers. Good job. Okay. Check the first block. Oh, yeah. That's true. The Matrix words actually do say censored slow. Yeah, he did good job with this website, man. Here's the link, lads. Alrighty. Oh, you're a fresh graduate? Nice one. That's good. Welcome to the real world. It sucks. But okay, you will find your way through, don't worry. Yeah. And we'll chat more. I think like we will talk about like interviews and like I think I want to work on my resume this weekend. Let's work on the resume this weekend. That because I really need to. Yeah, that's great. CTF site would be amazing. You would need some funding, but that would be great. Whereas I think this is it for today. Enjoy, join the Discord, right? Enjoy. There will be more chatting there, right? You can ask if you have any questions with each other. collaborate, enjoy, have fun. This is your favorite censored hacker going to bed and signing off with a big buy, an amazing song. So, yeah. Have a great night here. Thank you, bro. We steal money from rich and make ourselves rich. Yes, that's actually the right way. Awesome. So till then, thank you so much, lads. Hope you guys have a great one. This is your favorite censored hacker. About to play one of my favorite songs. I don't know what to do with SWE Pen Testing Cloud. I will say apply for all the jobs. Whichever you can get the job in. Apply. Just work with that. Just do that job. Just start with that career, right? Why I can't hear this? Can you guys hear the song? No, you can't, right? Why the song is not audible? I failed Red Hat interview. Oh, the behavior. It's okay, man. Those behavior ones are like, honestly, why HR creates those, nobody understands. It's like, it's one of those which is like, there's no point in having them. You're a hacker. What they talk about, what they are yapping about. I know why. Why I can't hear any song. Once again, one second. What the heck is going on? No, like the thing is, I can't hear anything on my desktop now. This got disconnected badly. You guys can hear me, right? Like, great stuff. Love Windows for all that it is. Lead code we can do on the weekend, like we can do interview and then we can do lead code if you want. Yeah, but I can't hear anything. Like if I'm trying to play a song, right? The glitch song. Can't hear it. So you see this? It's playing. Can't hear it. Yeah. Yeah, sure. I'm down for interview rounds with like lead code and stuff. Sure. Okay, let's do that then. Let's do that for the weekend. Okay, lads. Enjoy your day. We'll work on the lead code and our interview terms. Till then, thank you so much, lads. Hope you guys have a great one. This is your favorite censored hacker. Actually, we can do interview through the lead code one, or I can take the interview. Sure. We can, or I can ask somebody to take the interview. I can like talk to some people. Let's see if they can get the interview done. Okay. Till then, thank you so much, lads. Hope you guys have a good one. Sorry, no song today. I have no idea what's happening. But till then, thank you so much. Hope you have a great one. This is your favorite sensor hacker signing off with a big bye. Peace out, man. Thank you. Thank you all for joining. Peace out.